Hey to everyone. Before we go over our stamp, let's talk homework answers from last night. Overall, I saw solid work, so I'm excited about that. We'll see what questions we have. Number 1, I'm going to do A for what's on the left and then B what's for on the right, okay? Negative 6x squared plus 31. B, 18x squared minus 84x plus 90. 2, A, so what's on the left? 100x squared divided by x squared plus 4x plus 4. On the right, 10x squared, 2x squared plus 1 in the denominator. And then number 3 was more like a proof of sorts. So that one I can't necessarily put up, but we can go through. So which of these 4 would we like to see? All of them? Do you want to do this first or the stamp first? This? Okay. So let's go over number 1. Number 1 said, let f of x, that is a t. Let's try that again. Let f of x equal negative 3x plus 7. G of x equals 2x squared minus 8. Yes. Good? Okay. First, we're told find and simplify f of g of x. What is my guide? What's my starting function on this? F. So let's write that first, literally as a guide to know what we're going to do next. So f of x equals negative 3x plus 7. And what is going to be substituted into the function f? Right. So my new input becomes what? Exactly. So this means that wherever I see x, this is going to be my new input. So this becomes negative 3 times 2x squared minus 8. Literally following my model right here. Negative 3 times x, here's my new input. And then I bring down my plus 7. And to wrap this up, we're just going to use our algebra skills. So this becomes negative 6x squared plus 24 plus 7. Combine like terms, and again, negative 6x squared plus 31, and we're done. So as we work, this is why I say a solid effort, to me, is full credit on the homework. Because if you've really sat with the question, and now you're comparing your steps to mine, you clearly see how far along are we on the same page, and maybe where did we go a little different, right? Next, we were asked to do G. So this is a question for you guys. How do I read this? Yeah, good. G of f of x. So be careful. This doesn't mean multiply. That little open circle means composition. So this and this mean the same thing. What's my starting function? G. So in both instances, regardless of notation, G is coming first. So if it helps you to rewrite it like this, go ahead and do that. Otherwise, we can definitely read right from here. So let's work from G of f of x, because that seems to be a little more comfortable for us. I'm sorry. G of x, my starting function says what? Good. That's my guide. What is getting substituted into G? Which is what? 3x plus 7? Negative 3x plus 7. Good. Let's follow our model. So this is going to become 2 times negative 3x plus 7 inside minus 8. Is this right? What did I forget to write? The square. That'll change everything. Every detail matters. We talked about yesterday, when I'm working on this, nothing is wrong with kind of just working on that little piece to the side, because how am I going to figure out what this is? What do I have to actually figure out? Yep. So it's going to be negative 3x plus 7 times negative 3x plus 7. So we can work on that on the side and then bring our result back into our solution. What do we get when we multiply this out? 9x squared. Put that in a different color. I don't want it to blend in with the blue. 9x squared minus 21x minus 21x plus 49. Good. And then combining like terms in the middle, we get 9x squared minus 42x plus 49. And now we'll bring that back in. So this becomes 2 times 9x squared minus 42x plus 49 minus 8. And as of this, we're just working on our algebra skills of distributing 2 and combining like terms. So I get 18x squared. Keep going. Am I done? Super close though, right? We're just going to combine like terms here at the end. So 18x squared minus 84x plus 90. And we are done. So yes, when so much of this is based in our algebra, one little typo in our work could send us all awry. So pay attention to the little details. I heard a lot of what on number 2. How did number 2 go? Terrible. All right, let's work on number 2. It was okay. See? Okay, that makes me feel better. I like okay. Okay, so number 2 says h of x equals 4x squared. G of x equals 5x divided by x plus 2. And first we're asked to simplify this. What is this? What does this mean? H of g of x. These mean the same. H of g of x. What's my starting function? H. Okay? So that'll be our guide. So we're going to write h first. So h of x equals 4x squared. And my input is going to be what? Yes. Very good. This is going to be so much fun. I can just tell. Okay. So this becomes 4. Did we all at least get this far with the setup? Okay. So was it squaring the fraction that threw us off a little bit? Some of us? Do you want to work on it in here or off to the side? Okay. So off to the side, we're going to be working on 5x divided by x plus 2 times 5x divided by x plus 2. How do we multiply fractions in general? Just how do we multiply? Then straight across. So the top is not bad. What do I get when I multiply up top? 25x squared. But how about that bottom piece? We're going to have to distribute, yep. So the top is definitely 25x squared. We are all on the same page on that. We are expert multipliers, so let's just work on it right now. So x times x squared, keep going. Combining like terms gets me what in this denominator? Oh, careful. X squared plus 4x plus 4. Very good. We're going to bring this back into our work. So this now becomes 4 times our result, 25x squared divided by x squared plus 4x plus 4. We're super close to being done. Super close. When I distribute the 4, good question. So the question is, can we do this? Watch the screen. Can we do this? No. The only way that could happen is if I was actually able to factor out x squared from the denominator, end up with something in the middle, then this x squared would be able to cancel with that x squared. Factors cancel, not terms. Remember that from a couple weeks ago? So here's a perfect example of what that means. This would be an attempt to cancel terms, not factors. Because here, this is separated by multiplication, makes it a factor. Here, if we're able to factor this out, now this would also be factors. Factor, factor, yes. Factor, term, no. Follow? Really good question. We can talk about that more a little bit after. So we've established, thanks to her question, we definitely can't cancel those x squared. So there's really only one more thing we can do, and that's what? So what's the result? 100x squared. What about the denominator? Do I multiply the entire denominator by 4? No, good job. Because 4 is technically divided by 1. So, yes, you have something to multiply by, but multiplying by 1, does that change anything? No. So 100x squared, 100x squared divided by x squared plus 4x plus 4, and we are done. Because this 4 is technically 4 divided by 1. So we do multiply the top by 4, but if I were to do multiplication in the denominator, what am I multiplying by? 1, and would that change anything? No. So if it helps, draw your little invisible 1. Nothing wrong with that. The more you put on paper, the better the conversation in your head. Good job. Does everyone want a chance for fixing the next piece, or we still want to work on that one all the way through together? No. Okay. So we're still working with, we need to go back. I heard someone, oh no. I'm not sure how small I can make this. Is that good for people who need it? Okay. So the second part of this was simplifying g of h of x. Starting function is now g of x. Good. Again, I always look right here. That's how I know where to start. So what does g of x say? 5x divided by x plus 2. Good. And now what's my input? Can we try taking it from there on your own? Try. How's it going? Good? Ready to go over it? So I put up this first because I really want you to picture what you've got. No matter how crazy the fraction, no matter how crazy the function, we're following this as a guide. So wherever my input is, I'm putting in a different input. In this case, what's my input going to be? So wherever that x was present, we are plugging in 4x squared. What is the result in the numerator? Say that one more time. 20x squared. And then anything I can do in the denominator? No. How many people got this far? Why is this not done? Why did I write a different answer? Yes. So here we are going to be working with terms, but notice we'll be simplifying every term. What goes into all three coefficients? 2. 2 goes into itself once, into 4, twice, into 20. That's where the final answer came from. Simplifying. So this became 10x squared divided by 2x squared plus 1. Awesome, right? Because we can simplify all of the coefficients by a term. In this case, 2, they have a common factor.
All of them have a common factor.
Yes, all of them have to. Like if that was a 20, if this was a 20, look at the screen. If this was a 20, this was a 4, but this was a 3, you couldn't have done that. All terms have to be divisible by that same factor. Good question. Number 3, I will leave to you. If you didn't figure that out, you can check in with me. The main focus of the homework, though, was making sure our composition was on point for these first 4. Right? So with that, let's do a little summary. I started having a good conversation with someone at the beginning of class on notation. Oh, the stamp. How could I forget? So eager to get to my little half sheet. All right, let's go back and work on the stamp. Stamp. So remember, pencils down, no fixing anything. We get it or we don't. Pencils down. So my starting function was g of x, g of a in this case. So g of a equals 2a squared minus 3a as my start. We are going to be evaluating negative 5a as my input. So wherever I see a, I'll be plugging in negative 5a. This would become 2 times 25a squared plus 15a, which is 50a squared plus 15a, and I'm done. I'm hearing a lot of yeses. That makes me very happy. So whoever got the stamp, come on up. And then can somebody else pass these out? Adesolo, sorry, can you pass those up? Stamps right here. Fast, fast. Bam, 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 bam. Let's go, let's go. Good, good. Awesome, awesome. Yes. Yay. Sorry, that's not supposed to be a thumbs down.
You know.
I think you got twisted. Last call for stamp. Okay, before we do some more practice, this little half sheet is a really nice way of us getting all of our notation in the same place. So let's talk. Let's talk about this little half sheet real quick. Take a second. The directions are rewrite the function notation in its other form. No math is needed. So this is purely an exercise in rewriting in different forms. So for example, let me do one with you so you understand the point of it. We'll do 2. I'll do number 1 and I'll do number 4. How would I write this in its other form? Yes. Number 4, I'm kind of starting with this and I have to go back. Interesting. Very good. So in parentheses, f divided by g of x. So that's the idea, going back and forth. So take a second, make your way through the others, and then we'll talk about them. No math, purely rewriting. Yes.
What if you like f of g
Could be either. I would take both. So another way that I would take for that, Jasmine just brought it up. It's good. Either of those would be good. Good job. Yes. Great question. So she asked, what's the difference between 7 and 8? So this is the importance of being careful with how we write, because now there is a night and day difference between this. Oops. Uh-oh. What did Ms. J just do? Ah, crisis averted. Okay. This and this. What does this mean? What's this? Composition is what we've been doing for the homework, where we f of, that word of, f of x, g of f of x. So now if we keep this in mind when we look at number 7, this is saying f times g. So this breaks up to be f of x minus 2 times g of x minus 2. Whereas here, how do I read this? F of g of this input. So first, I would figure out what g of x minus 2 is, and then that would be substituted into f. Same idea comparing numbers 3 and 6. Here, what operation is happening? Multiplication, f times g, which is why we broke this up to be f of x times g of x. But here, this is g of f of x, composition. So that was the focus of this little exercise, is to really help us to understand that the smallest differences in notation can have a big effect on what the problem is actually asking us to do. Yes? Cool. So keep that to the side. Mentally keep everything we just talked about in mind. Let's do a couple more examples for composition. So we're going to add on to yesterday's notes. Remember, yesterday was a half day, so we didn't really get as far. We did get a solid start, which is what led to great homework assignments. Really nice job on that. Yes. The slides for that? Yes, I do. Yes, after class, I can print them off for you. Okay? Okay, composition continued. Now the function we worked, so you know where we are in our notes, the function we worked with yesterday, 2 functions, it was f of x equals 2x squared minus 6x plus 1, and g of x equals 3x minus 9. Can we do this? How would I read that out loud? Why not? What's my starting function? G, so let's do that. So my starting function is g of x. What's my input? Yeah, nothing wrong with that. We're plugging a function into itself. Why is that possible? Because that's what makes math awesome. Yeah. There's nothing that prevents us from being able to do that. This is an expression just like this is an expression. So mathematically, there's nothing that prevents us from plugging in an expression into a function, even if it's itself. So this becomes 3 times, and you can finish this. Let me know if we match. Yes? So this is just a quick, this is not necessarily new, but what is new is g of taking function composition of itself. G of x is possible. So there's 2 more that I would like us to work on before we pass out some practice. We're actually going to work with the same functions we did in the warm-up. So you could copy those down. H of A is negative 5A. And G of A was 2A squared minus 3A. But now I'm asking for think about that little half sheet we just worked through. How can I take this and write it in its other form to help me know what to do? Who wants to take a shot? How could you rewrite this? Jasmine? No, come on, you got it. You got it. How would you read this out loud? So I'm going to say what you just said, I'm going to write down. G of, oops, supposed to be a parenthesis. Smartboard, agree. Let's go. There we go. G of H. Perfect. Nice job. Well, let's see. So typically, if I had an expression here like h of x, we would start at g, yes? But as soon as we're starting to evaluate at a given number or given term, we're actually going to start from the middle because we need to know, we can actually calculate that input, right? So let's first figure out what is h of 4. So the strategy changes when we're evaluating numbers versus expressions. When I'm evaluating a number, we're actually going to start from the middle because we can actually figure out what that input is. So let's see, h of 4 would equal negative 5 times 4. That's negative 20. So h of 4 equals negative 20. So now we know we're actually going to be figuring out g of negative 20. See how that works? It's pretty nice. So go ahead and find g of negative 20, and then we'll compare. Right there in the corner. There's a roll right there. Yes. So let's see. This 2, we're going to leave alone for a second. We're just going to look at the negative 20 squared. What's negative 20 squared? Yes. So the square only applies to what's inside. What are we getting as an answer? Me too. Good job. So when we have a numerical input here, when we actually have a number, 4, 2, -8, 7, the strategy changes. Work from inside first because you can actually figure out what this is. One more. Put your game faces on. This one is going to be fun. I know. Okay, check this out. So g of x equals 2x minus 2. F of x equals x squared plus 3x. Find Come on. How awesome is that? Okay, so let's all start together. How could I rewrite this? Following what Jasmine had told us, the same idea. How is this going to be rewritten? G of f of x minus 2. So where should I start this? We can figure out what this is. So if what's on the inside of that composition is something you can actually work on, go work on that first. Work on this first. That's the idea of these two examples. If there's something you can work on first, do it first. So let's figure out f of x minus 2. If you're not sure how to start, always come full circle. What's the guide? The guide is f of x equals x squared plus 3x. And now under that, go ahead and write f of x minus 2, and you should be good to go. Yes. So for this over here, I kind of worked on it in my mind. So if we come over here, watch, x minus 2 times x minus 2. Let's distribute together, right? So x squared minus x times x is x squared, x times negative 2 minus 2x, negative 2 times x, negative 2 times negative 2. And then if I combine negative 2x and negative 2x, I get, right. So now that you've figured out what the input really is going to be, what are we plugging that into? So g of x was what again? So what this really is going to become now is g of what you just found. Cassie, 2 seconds.
Good morning, East River High School. Today is September 23rd.
So go ahead and keep working on that. Remember, we usually have a minute or two after the pledge.
I pledge allegiance to the flag of the United States of America
Here.
and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Students are reminded to be responsible by being on time and in uniform, to be respectful by treating others with kindness, and to be safe with words and actions. Have a great day.
So while you're working on that, this type 3 that we're going to start over the weekend, only a piece of it, it's meaty. It's not hard, it's just meaty. It involves everything we did for domain restrictions, function operations, so adding, subtracting, multiplying, and composition. So your homework for tonight is only going to be up through number 7, the first page, both sides. If you choose to go farther, you're only helping yourself, you're just going to help yourself out for Monday. But the official homework that I'm checking is just the front page, both sides. Okay? No. You can become an awesome helper to other people. So let me pass this out. Are we still working? I didn't hear the bell, so we're still working on this, right? You finished? You guys checking answers with each other? So Michael, that wasn't the bell. Let's unpack, please. We're comparing answers for that. Then, I did not hear the bell. Take out that and compare answers with each other. Yeah. Sitting down. Compare answers. What did you guys get? Did you guys compare answers on that one? Tiana, are you comparing answers on that one? Awesome.
Wait, hold on. I know how you got this. Wait, I think I must have. Good job. No, okay.
What are we getting for an answer? That's sounding right. Let's see. So this part is relatively not bad, right? Yes, the answer is 2x squared minus 2x minus 6. Good job. So remember, this type 3 is going to involve everything we've worked on over the last week. Domain restrictions, even root, rational functions, operations, adding, subtracting. So that little half sheet will be a big help to keep things straight. And composition. What's the homework? Front and back of first page only. But if you go farther or try farther, that will help you out for what are we going to do Monday? Keep working on it. So the more you get done, the better, right? Nice job today. Happy Friday.